As we continue on to part 2, we want to remind everyone that there are some topics we haven't covered in our curriculum in Chapter 8, so we'll be passing those over. But we did do this in 8.7. Here we have a formula, and we are asked to identify the vertex. And as background, remember this is set up in what we call the vertex formula. And our vertex, by definition, we said was HK. So we can sort of pick it right out of there. Now, the K part is this 4, but the H part, as you look at it here, is the opposite sign of what we have here. So this is a positive X, so it goes in here as a negative X. And we covered this in an earlier lesson if you want to watch the video on how this all works. Now, identify and draw the axis of symmetry. Well, the axis of symmetry by definition is our X term, which is right there. And find the maximum or minimum function. And in this case, it will be our minimum because our A term here is positive. When that is true, the parabola opens upward, so you end up with a minimum. And that minimum function will be negative 4. Now, they want us to draw the graph, and for this, we already have our vertex, so we can put that right in here. -2, 1, 2, 3, 4. So there's our vertex, and our parabola is going to come up along this way. Now, because we have a 2 there, this is going to be more narrow than if there wasn't a 2 there. Remember, as this number is just a 1, it's a certain width to our parabola. As these become fractions, it broadens, it widens out. And then as it becomes whole numbers here and they increase, it gets closer to your axis of symmetry. So let's take a moment, we'll plot the axis of symmetry, which is a -2, which is right there. And then we'll sketch in our parabola. You may be able to use your graphing calculator, so otherwise you would have to do lots of plots. So the graph looks a little bit like this. Again, when you do it in MATLAB, it's much easier to do because you can use a parabola tool. All right, let's go on. Now, for number 19, they're giving you the function. They want you to find the vertex in the axis of symmetry and then graph it. Well, for this, that went up by itself here. For this, what we want to use is the background that I'll give you right now. And that is that here is your standard form of the quadratic expression or equation. and this is the modification of that into the vertex formula. So let me go over the strategy of converting this then into this. And again, there's a full lesson of this in a previous video. Here it's just a little review. So let's write it out here. We have 4x squared minus 8x minus 1. Well, the first thing we do is we're going to take this negative 1 and move it out here. We have to separate it. Then I'm going to take these two terms and factor out the 4. And I want to then, in this part of the expression, make this into a perfect square trinomial. Now in doing so, we're going to complete the square. Again, we've covered this in an earlier lesson. We're going to take the square root of this, which goes right here. We use this negative sign. And then we say take half of your b term, which is, in this case, 2, and you get a 1. Now we're going to square this 1. We square it and we get a positive 1. This is now a perfect square trinomial. But we've added a 1 to this. What we need to do is subtract a 1 now. So this 1 that we've added here, we're subtracting there. But keep in mind, we took this out of there, so we have to multiply this by that 4 that's right there. And this 1 is still there as well. So now we go, negative 1 times 4 is a negative 4, and another negative 1 makes this a negative 5. And of course we need this 4 here. So now we have converted from standard form into the vertex form. So for question 1, find the vertex and the axis of symmetry. Well, the vertex, by definition, let's put it right over here for the vertex. It's going to be, this is our k, which is a negative 5. But for our h, we have to use the opposite sign of that. So that's going to be a positive 1. So this is our vertex. And we said our axis of symmetry was a 1. So let's put in our axis of symmetry now as a 1 right there. Let's also put in our vertex, which is 1, negative 5, which is right there. Now notice our A is positive, so our parabola will be going up. And notice it's a 4, so our parabola is going to be quite narrow. We said if it was just a 1, it would be sort of broad. If it was fractions, it would be very broad. And in the previous example was a 2. So this is even going to be closer to the axis of symmetry. So again, whatever technique they allow you to use to graph, we will graph this. It's very difficult to graph with this pen that I'm using, but this gives you an idea of what the graph is like. Okay, let's go on to number 20, where they want us to find the x-intercepts and the y-intercepts of this particular function. Now, as background of this, our x-intercepts will be there, and our y-intercept will be there. So, for our x-intercepts, what is our value of y? Well, it's 0. So, let's solve that. So we have 0 for our y value, and we're just going to factor this. It's nice and easy to factor. And we need a plus here and a minus here. So here x will be a 2, and here x will be a negative 3. And what did we say was our y value then? That was 0. So this is one of our x-intercepts, and this is one of the other x-intercept. Now for our y-intercept, we want to have that x now, our x value is going to be 0. So remember, this is a y, and if our x value is 0, this would be a 0, this would be a 0, then our x value is going to be a negative 6. So when x is 0, our y value is negative 6. So this is our y-intercept. So our y-intercept is sort of there. And again, this is just for diagram purposes. Actually, this one should be perhaps a little bit over, but it shows you this would be like this one, and this one is this one, and this one is this one. And how did we get it? Well, we used in our formula this as 0, factored it, got finding the zeros is actually what this is. And for this one we had y here, and then we put x as 0. That gave us our y-intercept. Okay, let's go on to this next one and we'll solve that. Now the first thing we're going to do is get rid of our 3 here. This is just one term, so if we multiply both sides by 3, the 3's cancel out here, and we get 3v, and I'm going to distribute the pi, r squared pi plus lowercase r squared pi. And now we're going to take this term, bring it over to the other side, and we get 3v minus r squared pi equals capital R squared pi. And if we want to isolate the r squared, we're going to divide both sides by pi, which is what I've done here. So let me get rid of this. And now to get rid of the squared, what I have to do is take the square root of this, and that, and the other side, square root of that, and then that will give me an r all by itself. And that is the solution for number 21. And as I look at these other examples, these are not in our curriculum. Number 22 isn't. That's in section 8.8, I believe, and we only go up to 8.7. This one might not be in our section, but we can take a look at it. It's pretty much easy. Does this look like it's a linear function? Do you see sort of an upside down parabola here? Yes, so that would be a quadratic function. And we didn't do anything like that. And this is an 8.9 where we do inequalities. And these are some of the real challenging ones that we're not going to be doing either. So this will wrap it up as a little brief review then of testing in Chapter 8.